All right, so we're starting Unit 2 today, and as I always start off with the vocabulary, these are just some terms, and some of you may have found out how beneficial knowing those terms were and actually answering some of the questions on the test last time. So scroll down to those, and we're starting off with classification of matter. Now, I remember when I taught at Avon that there was a student that said that they got in trouble for using the term stuff in junior high. Well, stuff is a great word for describing a lot of things. And you're more than welcome to use stuff in here if you're not exactly sure what it is. I like that. So matter is the stuff in which the universe is composed of. And it has two characteristics. And it actually occupies space. So whenever we look at matter, it occupies space and it has some mass associated with it. As you know, there are three states of matter. There's solid, liquid, and gas. There actually is a fourth one, but we're not going to discuss it in here, and those are plasmas. I know. Those are the fun ones. Yeah. Physical and chemical properties and changes. Again, this should be information that you are very, very familiar with. But again, sometimes we just need a refresher. When we talk about physical changes do not result in the formation of a new substance. So, for example, if I had, say, some solid water, and I added some heat to it and made it into liquid water, and then added even more heat to it and changed it into a vapor, is it still water in all three of those states? Yeah. So that is, by definition, a physical change. So it doesn't change regardless of what I'm doing to it. Now, if I react it with something, then that's a chemical change. And whenever we talk about chemical changes, we are finishing with something different than that which we started. So, like, for example, if I look at water, what is water made up of? Yeah, so it's made up of hydrogen and oxygen. And we'll later learn that we'll write these equations like this. So if we have hydrogen gas and oxygen gas, first of all, what state is it in at room temperature? Don't say Indiana. Is it a liquid? Gas, yeah. So hydrogen and oxygen are a gas where water is a liquid. So when we change water into hydrogen gas and oxygen gas, we've already changed the properties. We've changed the way that it behaves. If I take a match and I throw a match into a sample of water, liquid water, what happens to the match? It gets extinguished. It gets put out. However, if I throw that same match that's lit into oxygen or hydrogen, what happens? It's going to explode. So totally different properties that are associated there. And a chemical change takes place there. Now, really important, whenever a chemical change is taking place, the stuff that you have is different. It will change. Sometimes for the good, sometimes for the bad, but it will change. So there is never an exception or an example where you have a chemical reaction that's exactly the same as when you started. If that happens, by definition, that's a physical change. And I have a really nasty example of a chemical change here with the sugar, and it's getting heated up and turns into this black, nasty mess. So don't ever do that at home. That'll.
What if you've already done it at home?
You already did it at home? Perfect.
It was for like a science experiment, like the fourth grade.
Yeah. And your teacher told you to do this?
I don't know.
Okay. Don't always listen to your teachers. All right. Physical properties. A physical property is a property that's associated with that stuff and doesn't change. So, like, for example, and I was speaking with a student in first period, if I look at a sample of gold, we all know what gold looks like. What color is it? Gold. Yeah, it's golden color. And if I compare that to, say, silver, it's kind of silvery in color. So if I look at gold and silver from a distance, I can differentiate between those two. I can look at it and say, that one's gold, that one's silver. Why? Because of the physical property of color doesn't change regardless of how much we have. All right. So physical properties help us to identify what it is that we're looking at. It's kind of nice. Physical property is a quality or condition of the substance that can be observed without changing the substance composition. So if you heat it up or you cool it down, it still should look the same. Now, it might not be in the same state, but its composition is the same. Chemical properties are associated with things that change due to the chemical nature of the matter. Like, for example, liquid water doesn't burn. Hydrogen loves to burn. That's a chemical property. Okay? So that's a great one. And the ability for a substance to undergo a specific chemical change is called a chemical property. So, like, I can have certain things that I can mix together. So if I take baking soda and salt and put it together, what happens? Nothing. Okay? Because the chemical properties of those two, they don't care for each other. But if I take baking soda and vinegar, they love each other. New things happen. There's a reaction. It's kind of like people. Some people you get along with and you interact and have a reaction with. Other people are like, yeah, I'm okay with that. Don't have to do anything with them. All right, so to identify a chemical reaction, keep in mind that the properties of the stuff that you're starting with changes. Okay, so they'll have different properties when we finish. And evidence of a chemical reaction, here are 4 pieces of evidence. So one of these 4 have to take place, and in some cases, more than one of these will take place. Like, for example, the release of a gas. So if you mix 2 things together and you see a gas or a cloud forming, if it's colored, in other words, if it's white, black, brown, whatever, run, because it's toxic and it could kill you. Probably won't be very good for you. If you see a clear gas, then there's a chance that it will be okay. I mean, it might not be very pleasant, but it might be okay. The color changes. So later on in the year, we're going to mix some things together that the change or the color will change for that substance. The formation of a precipitate, we'll actually spend about a week and a half talking about that. That's whenever I take 2 things, mix them together in a solid form. Okay. And then the last thing is a change in heat and light, aka an explosion takes place, or something's burning. So anytime that something's burning, you have a chemical reaction taking place. That's not a physical change. And keep in mind that every single time we have a chemical reaction or a chemical change is taking place, you're going to have a change or an exchange of energy. So somebody's going to get warmer, somebody's going to get cooler, and sometimes it's not going to be real obvious which one it is. But there will be an exchange in energy. And also, new stuff is going to form whenever a chemical reaction takes place. Again, I think I said that a couple times. Now, here are a couple terms that we need to know. Reactant and product. Reactants are things that we start with. Okay. Products are things that we finish with. So hopefully we'll talk more about that a little bit later on. And then in a chemical reaction, we never, ever, ever, ever lose mass of something. So like, for example, I've got an illustration here, bottom. And this is due to the conservation of mass. So here I've got two vials of something. Now I'm guessing one of these is like lead nitrate, and the other one is maybe like sodium chloride. And so when I mix these 2 together, or before I mix them, the mass is 43.43 grams. Okay, whatever. Then if I mix them together, now I form a precipitate where it has some lead chloride and then some sodium nitrate. Okay, but more importantly, the mass has not changed. So we can mix and we can form some new things, but according to the law of conservation of mass, that mass remains the same, and it should be the same. Now, I'm kind of surprised because if I touch something, I'm going to leave some oil and some cells behind, so they must have cleaned up those vials before they weighed them. Okay. And let's see here. Oh, and then the last thing is intensive and extensive properties. So when we talk about extensive and intensive properties, probably the best way to explain extensive and intensive is to make it a picture here. So let's say I've got a coffee cup and a swimming pool, and these are not to scale. So I'm going to put on here, not to scale, obviously. And let's say that the pool is like 50 meters long. We have a 50-meter pool here. And let's say that this can hold maybe 300 milliliters. Okay. And let's say that we fill the pool and we fill the coffee cup. Okay. First thing I want to ask you is, if I look at these two samples of water, what is the boiling point? Does anybody know the temperature in which water boils at? Don't say 212. This is the Celsius world here. 100. So these both boil at 100 degrees Celsius under normal atmospheric conditions. So when we look at how much water we have, as long as it's water, it'll boil at 100 degrees. That is an intensive property. Intensive properties don't change regardless of how much you have. Okay? Intensive properties do not change regardless of how much we have. However, let's say that here, let's do this. Say I take a Bunsen burner, and again, this is to scale, so they're the same size Bunsen burner. If I add a Bunsen burner to underneath both of them, so I've got this big amount of water in the swimming pool, and then I've got this coffee cup amount, which one will boil first? The coffee cup amount of water or the swimming pool amount of water? Coffee cup. We all have seen that before. This is an extensive property. It's based on how much you have, the volume, the mass, things that can change without changing the substance. So getting to the boiling point or getting the substance to boil is an extensive property. Questions on intensive and extensive? Okay. All right. Well, that, my friend, is the lecture for today. So the homework is 1 through 10. And let me also show this to you, just to help you learn your elements. If you go, let's see here, I've got a couple minutes. If you go over to, let's actually get to yours. Go to the 52 elements names and symbols. These are the 52 elements, names, and symbols that I will quiz you over on Friday. Okay. So what I'll do is I'll have half of these where you have the symbol, you give me the name. The other half is the name, you give me the symbol. Okay. Now, if you click on this, practice names and symbols, it'll take you to a memrise. Anybody done memrise? Okay. And this will help you study, I promise. It'll pop up here. Okay. And what I have are all the elements here, and you can see who's already in the leaderboard here for today. But to learn these, you click Learn These Words. And what it'll do is you can either go through the introduction, boron, and then you have to pick which one is boron. Okay. But there's a clock over here ticking down. Yeah, the faster you are, the more points you get, so to speak. And then if you let time run out, sorry, you're a loser. Okay? Makes sense? So, but do this after you finish the homework. We have plenty of time for you to do both of these today. But this is a good way for you to help study for the 52 elements. And what's nice about that, notice how I missed boron? Well, it's doing it to me again. So now it's like, oh yeah, and then hydrogen. So if you've never worked with memrise, it's kind of fun. So I've heard.